Number 10, how many four-letter sequences of not necessarily distinct letters from the set A, B, C, D satisfy the property that no instance of the letter A is adjacent to the letter C, and no instance of the letter B is adjacent to the letter D? Now, we know that the letters are not necessarily distinct, which does throw a spanner into the wrench, or into the works. So notice, first of all, that we can do casework on the number of distinct letters in the sequence. If there are four distinct letters in the sequence, aka all four letters are used once, then A and C have to be separate from one another by at least one space. If they're separate from each other by two spaces, aka on other ends of the sequence, and the other two letters are in the middle, then the B and the D are going to be touching or adjacent to one another, so that doesn't work. So A and C have to be either the first and third or the second and fourth letters in the sequence. We have two choices for how these positions are, for which of these positions we choose. And then there's going to be two ways to order the A and the C. They can either have A in the leftmost place and C in the rightmost, or vice versa. And then there will be two ways to place D and B in that sequence, for a total of 2 cubed, or 8 possibilities, when the four-letter sequence has all four letters in the set. What if there's 3 letters in the set, or 3 distinct letters in the set? That means that one letter is excluded. We have 4 choices for which letter is excluded. Now, that means that we're going to have one pair of 2 letters that cannot be directly adjacent to each other, and one unrestricted letter. So one of the 3 letters in the sequence has to appear twice. If there are 2 instances of a restricted letter, then there's 2 choices for which letter appears twice. And then there's going to be 2 ways to order the sequence, because the unrestricted letter has to be in between the restricted letters. So that's the case where the repeated letter is a restricted letter. However, if the repeated letter is unrestricted, then one instance of it has to be between our 2 restricted letters, and the other one can go anywhere in the sequence for 3 other options. And there's still going to be 2 ways to order the restricted letters. So in this case, there's going to be 3 options for where the repeated version of the unrestricted letter goes, times 2 ways to order the restricted letters, for 3 times 2 options in that case. And multiplying this out, we get 4 times 4 plus 6, or 4 times 10, which is 40. Now, if the sequence contains 2 distinct letters, then first of all, because there's no way 4-letter sequence with exactly 2 distinct letters to not have both of those letters touching one another at some point, which means that we can't have an instance where the 2 letters are A and C, or the 2 letters are B and D. That means we have 2 choices for the letter from the set of A and C to appear, then 2 choices for B, or for which of the set of B and D appears. And then if there's 4 ways to pick which 2 letters are in the sequence. And then additionally, we can do a little bit more casework based on whether we have 3 instances of one letter and one of the other, or 2 instances of both letters. If there's one letter that appears 3 times and one letter that appears once, then there are going to be 2 ways to choose which letter appears 3 times, and then there will be 4 ways to order the letters. We pick the location where the singlet letter is placed, and then the others fall into place. And then if both letters appear twice, then there's going to be 4 choose 2 possible sequences. 4 choose 2 is 4 times 3 divided by 2, or 6. And this comes out to 4 times 8 plus 6, or 4 times 14, for a total of 56 possible sequences. And then finally, if the sequence only contains one letter 4 times, then there's going to be 4 possible sequences: A, B, 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 C, 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 or D, 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 D. So the total number of 4-letter sequences that satisfy the given condition is going to be 8 plus 40 plus 56 plus 4, which comes out to 108.
This is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care, and see you in the next video.